Hello there, everyone, and welcome to Westpak's webinar entitled Developing and Evaluating the Optimum Package. Thanks for joining us today. My name is Tim Eels, and I'll be the moderator for today's webinar, which is entitled Developing and Evaluating the Optimum Package. But before we start, let's take a moment to make sure everybody's ready and familiar with the webinar control panel. First, if you look on the right side of your screen, you'll find that control panel there, and you can minimize it with the double arrow button located on the upper left-hand corner of that window. You can also expand it, but this is an important window because this is how you're going to submit questions to the webinar team today using the chat pane at the bottom of that control panel. So if you'll, I'd like you to just attempt to use that raise your hand button here. If you could please click that button, and let's see if we can see some hands raised. Okay, I see a few of them. That's good. Looks like that's working pretty good. During the presentation today, we'll stop occasionally to answer some questions, so please don't hesitate to ask questions using that raised hand button. And I wanted to let you know, if we don't get a chance to answer your question directly today, your question is recorded on our system, and somebody from our technical team here at Westpak will follow up with you within a day or two after the webinar to address your question. So you will get an answer to your question. So I wanted to introduce today's speaker. Today's speaker is Herb Schueneman, and Herb is the President and Chief Executive Officer of Westpak. A little bit about Herb: he earned a bachelor's degree in packaging engineering from Michigan State, and he began his working career working for companies such as Western Electric and Clorox. After earning an MBA from Northern Illinois University, Herb and his growing family made their way to California, and he went to work for the Lancemont Corporation. However, after many years of working for others, Herb had other ideas, and he followed through on his dream of starting his own company. And in 1986, Herb founded Westpak. And he's created quite a legacy. The company's continued to grow slowly and steadily for the last 27 years. Our headcount's now up to about 50 people, split between two sites, San Jose and San Diego, California. Herb's a hands-on guy, and he really knows his stuff, especially about anything mechanical. However, in his spare time, he enjoys doing outdoor activities. He enjoys hiking and paddling as on the Monterey Bay in a beautiful laminated kayak, wooden kayak that his son built for him. One thing about Herb you wouldn't ever guess is he spends a lot of weekend time tending to his rose garden. He's got over 120 rose bushes, and many times during the year, he'll bring in vases full of flowers for all the ladies here at Westpak, and we really enjoy that. Another thing Herb really loves doing is teaching others, and for 27 years, Herb was an adjunct professor at San Jose State University, and he taught hundreds of students all there is to know about packaging and testing packages. A few of those students are test engineers and lab managers here at Westpak. Okay, Herb, I think it's time to pass the microphone over to you. So here you go.
Thank you very much, Tim, and I wanted to welcome all of the guests. Oh, very good. Technical glitch number one. I wanted to welcome all our guests. Some of you I know, and it looks like a lot of friends I haven't met yet, so welcome to Westpak and to the Westpak webinars. This is an interesting process. Westpak began, as Tim mentioned, 27 years ago, and a lot of our initial growth came about because of teaching endeavors, seminars originally, and later on moving into the electronic media, into webinars. So I wanted to thank everyone and welcome you aboard. Yes, I have grown some facial hair. You may or may not have recognized me in that get-up. Anyhow, The title of today's talk is really has to do with optimum packaging, and I want to make sure that everyone understands that an optimum package is within your reach. Optimum package is one of those nebulous items like the perfect storm and other things. It's often considered to be kind of a nebulous in the cloud concept, but it's really something that's available to you, and I wanted to make sure that everyone understood at least some of the techniques for getting there, and thus the topic of this particular webinar. As an overview, I want to make sure that you understand what we're going to be doing here for the next hour or so, actually about 45 minutes, because I'd like to reserve time for your questions. I'm going to review what's often referred to as the five-step procedure, and then explain the significance of each of those steps. I wanted to make a clear distinction then between package performance and package integrity, something I think that's been mushed over far too much in the past. I'm going to talk about the pros and cons of each of those, both performance and integrity testing of package systems, the typical applications, when it works, when it doesn't. I'll talk a little bit about the trap of mixing them up, which unfortunately many folks do, and then make some suggestions and recommendations that hopefully will help you in whatever you're trying to do with your particular design. There's a little bit of a background. This so-called scientific package development began in the late 1960s. It was an interesting time for me personally because I was getting my degree at Michigan State University at that time period, the late 60s. Yes, that's how old I am. And the concept was just being basically tossed around, checked out, if you will, at the school at that particular time. And as a laboratory technician, that was a fancy name for someone who swept the floor. I got involved in some of these initial tests, and some of you heard the war stories about some of the products that I used to bring home that had little dents on them or things like that, because that was how I populated a lot of things in those days. Anyhow, the result of all that effort, certainly not my effort, but efforts of a lot of people, was the so-called five-step procedure. And basically what it did, it created kind of a cookbook, if you will, out of this process, and made it easy to follow, certainly much easier than before. Prior to this time, package development was kind of a hit or miss function, and there wasn't really any cookbook or textbook or anything that would lead you into, do this step and then that step and then this step. So this so-called five-step procedure was a significant breakthrough because it was really simple. The first step was to define the distribution environment. In other words, quantify how severe the elements are that are going to cause potentially damage to your product when you ship your product through that environment. And I want to emphasize that every product has to go through that environment. That's kind of a common thing. Unless your customer's next door, you got to ship the darn thing. And therefore, it's very important that we know exactly what's going to happen when you ship it, and specifically what's going to happen that might cause damage to your product. Second step then is to determine the fragility of the product. So when subjected to these various inputs from that distribution environment, how much can your product take before it says, enough, or it breaks, or it fails, or it stops breathing, or whatever? Okay. So the second step is determining the fragility of the product, or ruggedness. Those two terms are kind of interchangeable. I heard one person describe ruggedness as the inverse of fragility, and that's kind of true. So the second step is figure out how rugged is your product, and how rugged in terms of what's going to happen in the distribution environment. So you don't really have to determine other things, just what about this is going to happen when I ship it. Third step then is to figure out, to quantify the characteristics of various packaging materials or processes or designs or whatever you want to call them that can mitigate the harmful effects of the environment before they get to the product. That's the function of a package. That's what we call a protection characteristic. Once you know those characteristics, then you've got the three legs of the triangle, three legs of the pyramid, if you will, that allow you to design the package. Step number 4, scientifically design the darn thing, make it work. And then finally, step number 5, you test it. And I put product package system there because it's important to recognize that these two have to work together as a system. Whenever you have an input, you can either have a product that's rugged enough to take it, or a package to mitigate the darn thing, or some combination of those two. Okay, so that's the 5-step. Let's go on and look at the first of these items, first step, if you will, and that's to define the environment. Make sure you understand that this is a quantitative analysis. You're putting numbers on everything. You have to measure everything. That's important. So how do you measure the distribution environment? Well, you measure the number and the height of the impacts that are likely to occur as a function, typically, of the weight and size of the package. And that can be relatively easily done. You also want to know the duration and intensity of the vibration input. Vibration comes from vehicles, and again, unless your customer's next door, you're going to ship it, and it's going to be shipped on a vehicle. Typically, trucks, rail, and aircraft. Those are the most common. You also want to know the height of the top load that's going to be stacked on top of this poor thing. Because compression is one of the key elements that's going to occur in that, the key hazards, if you will, that distribution environment. You also want to know the maximum and minimum temperature and humidity levels, because those can also cause problems. So these are the kind of things. There might be others as well, or you might pare down the list. But however you do it, you have to quantify the distribution environment. You have to put numbers on exactly what's going to happen. A lot of people are concerned about this distribution environment measurement thing, but I want to emphasize it's really quite straightforward. You can use a literature search. A lot of people have done this before. There was a publication called FPL 22, Forest Products Laboratory, report number 22. It was published, in the 80s, actually 1979, so close to the 80s. And it really did a great job, but it was summarized data that was collected 20 years before that, so it was kind of old, but still very relevant. Still use it a lot. If that is not okay, or if things like that are not okay, then you can easily measure your own environment using devices such as I show here. These are the Landsmont Savers. There's other devices as well. We happen to use these ones because we know how to use them, and they're really quite good, and you can actually get a lot of information very quickly. These things will record any kind of dynamic input, shock and vibration, impacts, that kind of thing. They'll also record temperature and humidity and altitude levels. So they're very succinct devices. The price has come down radically in the past 10, 15 years. So they're readily available. So once you get done with that, you basically define the environment. You quantified it. You put the numbers on it. The second step is to then quantify product fragility, or, as I mentioned earlier, ruggedness. And ruggedness in terms of mostly impacts and vibration. So for impacts, you want to know the maximum acceleration and velocity change that the product can experience before damage occurs. And this implies that you know what damage is. Most succinct definition I've heard is that damage is any condition of the product that you don't want the customer to experience. And then also vibration. Bear in mind that that impacts occur as a function typically of manual handling. That means people interaction. So it's a people function. So with the people functions, like everything else, it has a probability associated with it. Some things are going to get dropped a lot, some very little. Vibration, on the other hand, is a certainty. Again, unless your client is next door, it's going to be shipped. And vibration sensitivity can be more discerning than shock sensitivity, more damaging. So I would not rule out vibration analysis at all. In fact, we normally do it first. Shown here are a couple pieces of equipment that we use for that determination. On the On the right, you see the typical electrohydraulic vibration test system. Happens to be one of our newest ones at Westpak. So the product is placed on the table and is subjected to vibration input. The results are monitored and compared to the input, and you know its vibration sensitivity. Those of you who have studied this know that that's a transmissibility test. Don't need to throw out a bunch of big words, but that's really what it's called. On the left, you see a shock test machine, and the product again is placed on the table of the shock machine and subjected to various inputs. And when it gets to the level where it breaks, you have your fragility level. So it's relatively straightforward technology. There's nothing particularly magic about it. It's pretty well established. Some of you attendees have been through classes either at Westpak or at San Jose State or other universities, and so you know this. But what I want to emphasize, it's not just something you learn in class. It's something that we actually do, and it actually works. So that's step 2. Let's move on. Step number 3 has to do with quantifying the characteristics, shock and vibration in particular, of the various packaging materials, I'll call them cushions, that are available for your use. And again, these procedures are pretty well established for the shock sensitivity of cushions. ASTM D1596 is a good one. In fact, it's often used. There are some military equivalents thereof. There's some IEC, in other words, European versions thereof. But basically, they all involve just impacting the cushion and measuring the result. And then you change the static loading and the height and the thickness of the cushion, day of the week, and a few other things. And from that process, you develop either cushion curves or vibration response data in the case of vibration. But the point I'm trying to make is that you can quantify the response of these cushions and their ability to absorb harmful inputs. So that's the 3 steps. Now you've got everything you need to design that package. All the data is there. You can get it. And step number 4 then is go ahead and design it. You use the numbers. Again, it's a quantitative process to apply the correct amount of protection, shock and vibration, impact, temperature and humidity, if that's necessary, altitude also, pressure differentials, things like that, so that the product will be protected in the intended distribution environment. That's the process. And again, if we do it correctly, it seems to work just fine. And then moving on to step number 5, we'll actually test it. We got to make sure that our fantastic design here actually does what we want it to do. And again, as I mentioned earlier, we test the product package system because both have to work together to withstand the distribution environment. I should mention that in order to test these things, we subject it to a high level. I'm suggesting 3 sigma here, but who knows if that's actually the case. In other words, about 99% of the known inputs from the distribution environment. When you actually do your testing, you'll be able to take those quantitative inputs, or not the testing, but the distribution environment measurement. You'll be able to take those known inputs and create a spreadsheet, create a bell-shaped curve, so you'll know approximately where the 3 sigma level is, and you use that level in your step number 5 to actually test the product package system. If it passes, you know not only that it's a go, but you also know by how much it passes, and that's the advantage of this particular quantitative approach. Okay, and I'm going to really hone in on that whole process. But I do want to emphasize that this is a package performance test. Now, performance. What do you mean by performance? And clearly, different people have different meanings by that. If you look at some of the standards, which we'll be examining in a minute, some of them say package performance test, and it really clearly isn't the performance test. It's what I call an integrity test. So in order to be a performance test, in my definitions, and I do have to emphasize that this is not an industry standard by any means, it's simply, this is Herb's definitions. Performance test has to be quantitative. You got to be able to get numbers out of it. in order to see if it performs correctly. Okay, so that's an important distinction. I should emphasize that there is another kind of package test, and that is referred to as an integrity test. Okay, so an integrity test is not a quantitative analysis; it's a qualitative analysis. Okay, so in other words, you don't collect numbers when you actually do the test. What you do is you simulate the distribution environment in the laboratory, and then you subject the product package system to that, and then you make some judgments about it. You know, is this thing okay or not okay? So it's a qualitative test. There's no numbers generated. So that's an important distinction. And again, probably one that most people are not familiar with, but one that I really want to emphasize as much as I can. Tim, are there any questions that have occurred in the first 15 or 20 minutes of this presentation?
Well, thanks for asking, Herb. So far, we're pretty quiet on the questions front. So
Okay.
Continue on.
No problem. I do want to emphasize that if anyone has any questions, raise your hand, electronically speaking, at any point. Okay. Let me do a little more background then on this package integrity, because I think it's important that people understand that difference, or at least what I perceive to be the difference. So as I mentioned earlier, it's an attempt to bring the distribution environment into the laboratory. So basically, you measure what happens in truck shipment, and then you bring that same vibration profile, if you will, into the laboratory and subject the product package system to the most intense portion of this. Again, it's not necessary, at least most of us don't think it's necessary, to simulate the exact truck. What you do is to simply measure that environment and then bring the intense portion into the laboratory to shorten the test procedure. It's also important to note that some people have caused questions to be asked about this so-called intensity level and time trade-off. And some of the conferences that many of you have attended, and I have as well, point out that this so-called simulation in the laboratory using compressed data, where you actually increase the amplitude and decrease the time of the exposure, may not give you the right results. So the jury is still out on that particular topic. However, what we're trying to emphasize here is the fact that this is an integrity test. There's no numbers involved in it. ISTA procedures, International Safe Transit Association, and many of you are familiar with those. Those are all package integrity tests. Now, they may not say that on the front, on the top. ASTM D4169 and the 7386 procedures, they will in fact say package performance on the top. Well, I disagree with that. They're all qualitative tests. They're not quantitative. So that's the difference. Tim, what's up?
Say, Herb, there's a good place to ask a question. One question came in was, does Westpak rent out the monitors?
The answer to the question is yes, we do. In fact, we use them for client services. We don't actually go out and measure the environment just for the fun of it, believe it or not. Although I've done that, I should ask. But yes, if this is a service that you'd like, Westpak does offer it. By the way, I'm not going to burden everyone with Westpak services here. I don't think that's important. I've got a nice website that'll tell you that. So I'm going to stick with the actual, verbiage and the concepts and the theory rather than our practice. But if you got a question about it, shoot, I'll answer it. I'm certainly not above that. Let's move on and talk about the pros and cons of package performance versus package integrity. Hopefully this will give you a little better idea of why I decided that there's a good reason to separate the two. Again, package performance is a quantitative test. There's numbers. Gives a clear pass-fail evaluation, not just an indication. The most important thing, in my opinion, is it gives a good margin analysis. What do I mean by that? You know not only if you pass or fail, but by how much you pass or fail. So you can say, well, this thing is twice what I need, or 3 times, or half in the case of a failure, or things like that. So it's a very good tool most of the time for margin or headspace analysis. Both those terms are used kind of interchangeably. That's very good for evaluating several different options in your package. In my opinion, it's probably the strongest tool for optimizing your product package system. In other words, to evaluate the trade-offs between those two. Suppose it would take a very expensive package to give you the protection you need, and you can take some of that cost and put it into the product and ruggedize the product so it doesn't need that expensive a package. There's many examples of that actually happening, and if you think about it, the package is an expense item. It gets thrown away at the end of the cycle, but that same effort or cost put into ruggedizing the product remains with the product for its entire life cycle, and may in fact cause a whole lot better end result in terms of customer satisfaction than an expensive package. So you can make those judgments using a performance test. You cannot make those judgments using an integrity test. Logistics and supply chain work is much easier and straightforward using performance quantitative analysis. And then, as I mentioned earlier, you can evaluate the trade-offs between product ruggedization and package cost. Okay, so what's bad about this performance test? Well, it's more expensive, and it takes longer, requires instrumentation. Accelerometers typically, strain gauges occasionally, load cells occasionally. And so it requires a little more savvy in conducting the test. Those of you who have gone through any kind of packaging dynamics classes know that it's it can be a little head scratching, but not bad, not bad. Conflicts can arise between the various requirements. Suppose you do this analysis correctly, and you say, well, this package is great for impact, but it's terrible for vibration, or vice versa. So those not only can arise, but often do arise. So it takes a little savvy to figure out how you get between those, that rock and the hard place. And it also requires, of course, that you have sensitivity data, ruggedness data on your product. So those are what I consider to be the perhaps the cons, if you will, of the package performance test. Nothing severe, but that's what happens. Let's look at the integrity test and look at the good side of that, the pros. Why would you do this? What's important about the integrity test? Well, it's been around a long time, and not, I shouldn't emphasize it. They have been, because there's a wide variety of them. They are generally simpler and less expensive to run. The original test involved dropping something on the floor and throwing it down the stairs, quite literally. It's important to point out that an integrity test may be good enough for some applications. And we'll talk about that more later, but I should emphasize that it might just be a good thing. It's basically what I call a simulation of the distribution environment. So imagine a big giant scooping up the distribution environment, bringing it into the laboratory and simulating it. That's kind of my mental process when I think about these things. It's got a pass-fail analysis, because you can check out the product at the end of the test and see if it works. And I think the thing that should be emphasized, it's widely used. It's understood. Conceptualization is very easy with integrity tests, because it's not hard to say, okay, that shaker looks like a truck, or that dropper, that looks like what happens when someone throws it. Okay. So there are many good points associated with integrity tests, and I don't want to leave you with the impression that there aren't. However, I should point out what I don't like about it anyway, or what I consider its bad points. And first of all, there's no margin or headspace analysis, so you don't know if this thing passes. Does it pass a little bit or a lot? I bet a lot of you have had questions from your supervisor, your quality people, your whoever, FDA, the Food and Drug Administration, how good is it? How much assurance do you really have in this whole package system? Do you have a little bit or a lot? And you really can't answer those questions effectively without the numbers. You can do it by huge sample sizes. That's probably the only way to do it with a simulation. And some of you know that some of your sample sizes get insane, really. But without the quantitative analysis, that's about all you can do. It's also the basis is the quality of the distribution environment measurement. So if you got a good measurement technique or a good definition, that's a good test. I should point out that over-packaging is common. We often use that approach. If a package fails, there's no good indication of how you fix the darn thing. And there's something I call procedure creep. Those of you who have been around a while know that these darn procedures change so that you can have a package system that passes one procedure, and they go ahead and change the darn procedure on you. And you got to redo the test because you don't know if it's going to work on the new one or not. So those are what I consider to be some of the cons, if you will, of this. Looks like there's a question or two, so let's take a break and answer those.
Good timing, Herb. I had one question about the distribution environment. Person wanted to know, take for example the distribution environment that packages shipped by UPS might see. What's needed to do that testing?
Well, certainly you have to define the inputs in terms of what might cause damage to your product. So if you hand the package to the UPS guy and assume that that they have white gloves on, there used to be a white glove service. It might still exist, I'm not sure. And assume that he's not going to toss it in the truck when you're not looking, or beyond that, you're kidding yourself. So you certainly have to measure impacts, the height of the impacts, the number of the impacts as a function of package size and weight. So certainly impacts have to be measured. Vehicles are used in that distribution environment, so it would be really nice to measure the vibration levels, and assuming that you're going to get good numbers or satisfied numbers from a single shipment is probably short-sighted. You're going to have a statistically valid sample size of the shipments. You're going to want to know the temperature and humidity extremes when you ship the darn thing. And it might also be nice to know other things. For example, the altitude level. If you're shipping on air shipment, or even believe it or not, truck shipment can have higher altitude exposures than aircraft. All aircraft are pressurized to at least 8,000 feet. Now there was one survey that said a feeder aircraft someplace in Colorado reached 22,000 feet altitude. Well, I have a hard time believing that, because that plane would have crashed. The pilot would have couldn't breathe. And no, they don't have supplemental oxygen in feeder aircraft. And so if you're instantly exposed to 22,000 feet, you're gonna have a very bad day, guaranteed. So my suspicion is that that data is probably an outlier. However, 8,000 feet is the typical number that's used for any kind of high volume shipping in aircraft, and you can easily get over 10,000 feet on a truck going over a mountain pass. So I would use that number. So answer the question kind of a long-winded fashion. Those are the kinds of data that I would collect, not just via UPS, but any distribution route. I wouldn't think of designing a package that was tailored to a given distribution route, because let's face it, you might design a package that way and be promoted because you did such a good job in doing something else, and all of a sudden, somebody else made the decision. Oh, we're going to use Express Pro or some other new service because they're cheaper or whatever, and they use different inputs. So it would be very dangerous, in my opinion, to tailor a package to a given distribution cycle or company or anything like that. Any other questions, Tim?
Yeah, Herb, had one more. It's probably a good one to ask right now. Person wants to know if the performance test would be more applicable to the packaging development and integrity testing be more applicable to package verification.
Well, again, you're playing with words. What do you mean by verification, and that kind of stuff. And I think that's one of the reasons that we have this huge disparity, at least from my perception, in the business right now. The term validation is often used in medical device or pharmaceutical related testing because they have to. It sounds good, I think. I suppose there's other reasons for it. It's often used. The term validation is often used in medical procedures. So it's something that's easily incorporated into the package system, which is the last portion of the product delivery. But again, I think that the key thing there is whether or not you can actually determine the fragility of the product. And a lot of times where you have package validation testing, which I would equate to integrity testing, it'd be very difficult to determine the actual fragility of the product because it's a lot of times it's not in a really well-defined package. It's in a pouch, it's in a tray, or something similar. So it's really hard to do that. We'll talk more about that a little bit later, but my suspicion is validation and integrity testing are pretty similar. Pretty similar. Let's move on. I'm going to creep into more Q&A space here if I don't move quickly. And here's a brief summary, and those of you who want to summarize the difference, or at least my definition of the difference between performance and integrity, can look at these lists. I don't encourage you to write real quickly and write all these down because this list will be available on our website shortly. I don't know how long, but within a reasonable period of time. Enough for you to have a nice ice cream cone in the meantime. So basically the difference is a quantitative analysis versus a qualitative analysis, and using numbers and the resulting headspace and the trade-off with product organization. Those are the big key benefits of the performance test versus the integrity testing. And I don't want to leave everyone with the opinion that I don't like the integrity test or I think it's deficient in some particular way. That's not the case at all. It simply has some drawbacks that I think everyone should be aware of, and whenever possible, I would recommend measuring things. So, having confused everyone, likely, let me ask this question and maybe answer it. Okay, Herb, since you've brought these things up and laid your definitions on them, which one should I choose? In other words, given my particular product, how in the world do I choose between them? What are the criteria that I would use to test one versus the other? So let's take the performance testing first. And again, remember this is a quantitative test, numbers generated. And as I mentioned earlier, this margin analysis is an extremely powerful tool, I think. And I think you will too once you've had the chance to use it. Most of my career has been in areas where package cost reduction was a big deal, and I'd be very surprised if many of you don't have that same criteria. Cost reduction, cost reduction, cost reduction. Remember, packaging is an expense, okay? It goes right off the bottom line of the company, P&L, profit and loss statement. So every dollar that you can take out of packaging goes directly to the bottom line, and that's a dual-edged sword. But I quite honestly have had positions where my job was saved because my cost reduction numbers were many times my salary, and the company would be dumb to eliminate my position. They'd be losing money. So the margin analysis is a powerful tool that can get you through tough times like that. It also can give your boss or you peace of mind knowing exactly where you're at. Rest easy, boss. We've got this thing covered 300% or 500%, whatever you want, whatever it takes to make the boss sleep at night. You can do that with a margin analysis, and you can't really do that, not near as well or not for the cost that you can with an integrity test. Often this extra cost can be easily recovered and more with the lower cost of the damage and shipment and the package cost reduction. Both of those are expenses. So very, very powerful tool, that margin analysis. I really can't emphasize that enough. I've been very happy with that. The next case, if you will, is the exact knowledge of the distribution environment is not really necessary. You don't have to have precisely the right numbers for everything, because again, this is kind of a stimulation. It's not a simulation. So if you test your product package system using very severe levels, for example, you don't really care whether this thing is shipped on an air ride truck or a lease string truck if it goes overseas, or if it's on this aircraft versus that aircraft. You don't really care because you really got it covered. So anything short of abuse, if somebody throws it under a bus, all bets are off. But in most cases, you're covered. The distribution environment may change. Okay. Again, those of you who have lived through the past 20 or 30 years of outsourcing stuff to Asia, for example, know that the distribution environment has changed rather substantially. But it doesn't much matter if you have a performance-based package development system. You're pretty well covered. You don't have the concerns about retesting based on new data, new information, or new whatever. Lastly, I'd like to emphasize that product ruggedization. Again, that's a word that you will not find in the dictionary. You might find it in Wikipedia. Find almost anything in Wikipedia. But you won't find it in the dictionary. And just think of it as the inverse of fragility. It's just a process by which you make the product more resistant to impacts and vibration, for sure. And again, I mentioned that the package gets thrown away at the end of the distribution cycle, but the ruggedness added into the product stays and can be available for basically the kind of customer satisfaction that we're all looking for. I'm always amazed when these controllers and Xboxes and things like that get pulled off the top of TV sets by very energetic players. Not all kids, by the way. And they hit the floor and bounce and say, "Oh man, goodbye disk drive." But an amazing number of those darn things, they put them back up and keep on going. Those of you with handheld cellular phones or pads, all those kind of devices, boy, believe me, the ruggedness built into those things makes a lot of sense. So that's why I really like this performance testing. However, I'm not going to leave you with the opinion that that's the only thing that you should do. There's a strong case, and many of you with medical device kind of products will know this, for integrity testing. It can be cheaper. Again, it's been around a long time, so it has that legacy built into it. People have been doing this since the 1920s. It can be quicker, depending on the sample size. It's pretty well universal. In other words, the distribution environment doesn't care whether you're shipping, lead or gold or anything in between. The truck really doesn't care. So the integrity test is a pretty universal thing. One size fits all. And I should emphasize that it's good enough for many applications. We have experienced clients who are trying to do quantitative analysis on a product package system that really doesn't really need it. Qualitative analysis is really what it should be. So, given all that, how should we proceed? How do I get this so-called optimum package, this mythical thing in the sky that we're looking for? What should we do? Before I answer that, I should emphasize that sometimes you just don't have a choice, and you should recognize that. If you have a non-breakable product, for example, let's suppose that you're the newest lab technician or chief at XYZ liquid company. So you have this liquid in a bottle, and it's basically non-breakable. So believe it or not, however, I had the same situation at Clorox in my early days, and we were able to use shock testing to design the package. We asked ourselves, what are people buying with a bleach bottle? They want to they want to contain the product, and they also want to keep it from breaking. So we actually redesigned the bottle using shock testing. So you got to be careful when you say that so-called non-breakable products, and liquids might be one of those. Non-cushioned packages don't really benefit from a quantitative analysis, because you're going to get numbers that are really kind of crazy. Again, most liquid products are questionable, and many consumer products, candy bars and toothpaste and things like that, you may have a very difficult time justifying a quantitative analysis, whereas a qualitative analysis, in other words, the integrity test, might be very appropriate. So we should recognize that those are very real scenarios. And if you happen to be faced with one of those scenarios, the best you can do is to, again, bring that distribution environment into the lab to simulate the effects on a valid sample size. And and hidden in those three words, valid sample size, is a huge thing, because depending on the validation required, you may need a huge sample size, which would then make the test very expensive, etc. But then you make your pass-fail decision. So bottom line, don't discount the integrity test just because I'm not putting it at the top of the flagpole. There are situations where you simply cannot use it as I've laid it out here. Okay? So what's Herb's recommendation? I call it Herb's secret sauce. Well, almost always, to get to the optimum package, I would encourage people to design and test by the numbers. I'm always amazed, just absolutely flabbergasted in some cases, how a lot of very expensive and very high performance, if you will, package systems are designed by seat of the pants. It worked before, or I had good results doing this, or Joe Smith said this thing never fails if you just do that to it. So don't test those things. You don't have any good faith in that, but design by the numbers and test by the numbers when you can. And I should emphasize, when you can. Whenever you can, I would highly recommend that. And then educate yourself and others about this, the reality of performance versus integrity. In other words, the value of getting the numbers, especially the headspace analysis and the ruggedization potential. So whenever possible, those are my recommendations. And then there's a third one, and it's a little more subtle, intuitive, if you will. Learn to interpret the data. In other words, the quantitative data from the performance test. I'm always amazed when we run a test like this, which we do a lot of, and the numbers are kind of like a fingerprint. There's no two test data number sequences that are the same. It's always different. They're kind of like a thumbprint, if you will, of that particular test. So, for example, the data will tell you whether or not the cushion is overloaded or underloaded. You can actually tell that from the shape of the response pulse. You can tell if a cushion system or any component of the package is fatigue sensitive, especially ones that act like springs, such as cushions do. And you can also determine the damping properties of the cushion material quite easily. Actually, all it takes is an impact test. Vibration is normally preferred, but you don't have to have that. And I declare, this is going to take a little bit of a leap on my part, and hopefully a leap of faith on your part. Packet optimization is relatively simple once the data is collected and understood. You can compare materials, you can look at the stability, and like I mentioned earlier, cost reductions are relatively straightforward. And that's a big deal, as most of you are aware, in the real world where dollars talk. So again, when we started this presentation, gosh, 48 minutes ago, I said that over-packaging or under-packaging or optimum packaging are really choices that you make. And again, I should emphasize that if you have the correct kind of product, and some of you don't, and I should keep emphasizing that, but if you do, one where you have the numbers involved, then the choice is yours. You can actually design and hone in an optimum package, and I think the benefits are very much worth it, as I've tried to emphasize over the past almost hour. So anyhow, my voice is about ready to give out, and your ears are probably wilting away, so I'm going to ask Tim if there are any other questions that I can address before we set you loose here.
Herb, that's great timing. Hopefully we've got some voice left to answer a handful of questions. Jason wants to know if the ASTM standards, and he didn't specify which one, but do ASTM standards cover all the distribution types? You know, whether it's overseas shipment, aircraft, truck?
Well, to the best of my knowledge, Jason, and everyone else that's interested, the answer is yes. I used to sit on those, on some of the ASTM committees, not all of them, and I know from my personal experience that whenever the distribution environment quantification was considered, the broadest scope, the broadest definition of that was always used. I can remember people who represented the railroad business, and they would always insist that rail data be incorporated. And there were people who represented shipping companies, ocean-going freighters and ships, and they insisted that their data be included, especially temperature and humidity stuff. Certainly there are representatives from the parcel companies, the UPSs and FedExes of the world, and those kind of folks. To the best of my knowledge, the people from the U.S. Postal Service kind of came and went, depending on whether or not their budget would allow them to go to the meetings or something. But almost always there were representatives from a variety of different places, and so I would answer yes. You wouldn't have to worry about the specificity, if that's a word, of the actual environment based on the ASTM standards. They do a pretty darn good job of being as broadly based as possible. Next question.
In terms of shock and vibration, which test would be most important? How would you prioritize those?
Good question, and this is something that we're asked a lot in the laboratory. Generally speaking, for heavier products, how do I define heavier products? Certainly over 100 pounds. You're getting to the point where the mythical UPS gorilla can't pick the darn thing up. So for those kind of product package systems, vibration is always more important. Why? Vibration is a 100% certainty. The probability of an impact in a situation like that is exactly that. It's a probability function. But vibration is a certainty. In addition, vibration can be every bit as deadly and damaging, in some cases more so, than impacts. So almost always, if we're looking at a package performance test on a heavier product, we'll always recommend that the vibration testing be done first, number one, and if samples are limited and we've only got one shot at this, you certainly want to do vibration first and then impact. For smaller products, lighter products, it's more weight dependent than size. Lighter products, think of it this way, it's not as closely coupled to the vehicle on which it's shipped. So it might not be touching the actual floor of the truck or the aircraft or whatever. It might be in a stack. It might be almost anywhere. So lighter things can be tossed, and when they're assembled from one place to another, or they're into some sort of transfer process, or they're being delivered, or they're anywhere in that whole procedure, that whole complex distribution environment, lighter packages are more subject to manual handling impacts, generally speaking, not always, but generally speaking. So the answer to the question depends on the weight of the product package system. Okay.
Another question, Herb, has to do with product fragility. And the question is, can you develop a package if you don't know the product fragility?
Well, unfortunately, the answer is yes. I say unfortunately because I've done it many times. And in a case like that, fragility levels are either assigned or assumed, or taken from previous generations of the product, or things like that. So yes, you can use the numbers with an assumed value, as long as you recognize that you're on thin ice, that you're starting from this unknown. So the answer to the question is yes. In fact, it's often done. We will often times do multiple orientations of fragility testing on the same product, not sanctioned by the procedure, but the economic reality, says that that's what you got to do, man. You go to the boss and say, I need 12 of these things for destructive testing, and they're only $250,000 a piece, and the boss tells you to go to lunch. Or maybe you got back from lunch and you had the wrong stuff to eat. So the bottom line is that you can make judgments and deviations from the exact procedure as long as you know the effects of those judgments and deviations, and can judge the effect that they have in the final product. But it's often done. It's very common.
Okay, Herb, another question had to do with the ASTM bandwidth during for resonance frequency. What if the resonance frequency falls outside the recommended bandwidth on an ASTM standard?
Well, if it falls down on the lower side, then you've got a real big problem, a lower frequency. In other words, you've got something that's hard to conceptualize. If the resonant frequency is on the higher end, you've got a fantastic situation. That means that the darn thing is so stiff and so rigid that you probably don't have a fragility issue. You consider that the two things are really related. It's not like you can't have a product that has a low shock fragility and have virtually no vibration sensitivity. Mechanical things tend to have characteristics. They're all spring mass systems, and therefore, if it has a very high natural frequency above the ASTM recommended levels, then typically that's 200 hertz. What that means is that product is pretty darn rugged. So you really don't have an issue. In addition, all the data tells us that the distribution environment is all low frequency. In fact, the whole reason that hydraulic shakers were developed was because of the low frequency requirement for distribution. Electrodynamic shakers, basically big speaker heads, can't get, or couldn't in the early days, get to lower frequencies because they didn't have the stroke, the displacement. They do now, but in the early days they didn't. So the bottom line is, if you've got a product that has a natural frequency above the level specified by most of the ASTM, what they call performance tests, I call them integrity tests, then you've got a really good situation because it's probably pretty darn rugged. You don't have to worry about it.
Well, Herb, that pretty much brings us up to our 1 hour time, so we're going to have to wrap it up. I wanted to thank all of you today for your participation, and especially those who sent questions. If we didn't get to your questions today, we will answer and address your questions offline. Also, regarding the webinar, you'll get an email from us that'll include a request to give some feedback, and we'd like you to please respond to that. If you've got a suggestion for a future webinar, please take the opportunity during the survey to respond with any suggestions you might have. Today's webinar will be listed on our website in the next couple of days. You can find it there, and I believe the email that you get back will also include that. And before I pull the switch here, Herb has one more comment. So Herb, back to you.
Thank you, Tim. I do want to emphasize that I don't want to leave those people who have the requirements to do a package integrity test high and dry, even though I encourage performance testing. So our next webinar next month will specifically address fragility analysis and package design, optimizing packages using the integrity test if it's required. So don't feel like you're high and dry or that I'm ignoring you. That's not the case at all. But we will specifically address that next month, and we'll send out the same notice. So if you got this notice, you'll get the next one. about that particular effort. So we look forward to helping you as well.
Okay, Herb, thanks for offering that. I look forward to the October webinar. So everyone, I'm going to sign off now. Again, my name is Tim Eels, and thank you very much for joining us today, and hope you have a great day and the rest of the week too. Take care.